Hello.
Hi, ma'am.
I sorry there was a little confusion. Since I don't regularly take class at this time, I was in another class and it took a little longer to end, so I got delayed. So so practically I have finished what I had to teach in alcohols and phenols. So today what we'll do is, instead of starting a new topic, I will just go through alcohols, phenols, and ethers, their questions from your textbook. So we'll try to solve the questions from your textbook. Is there anybody sitting in the classroom also? Are there any students in the classroom?
I have no idea, ma'am.
Okay. Because yesterday some people had joined from the classroom, so I was thinking. Okay, so we'll do a few questions from the textbook. Okay, so the first question that I would like to do is first practice. Write all isomers of C4H10O and identify the isomer which is prepared using propanone and methyl magnesium bromide. Okay. Identify means you have to name the isomer. So you have to write all isomers of C4H10O and name the isomer which is prepared from methyl magnesium bromide. Tell me. Quickly do it in 2 minutes and tell me the answer.
Ma'am, is this from book back or index, ma'am?
No, I will tell you the questions from the book also. While I'm
Yes,
doing
ma'am.
that, I'm just giving you this. I'm going to do the question systematically from your book now after this. How was your maths test today? All of you did?
Fine, ma'am.
Okay. Did you find the answer?
Doing, ma'am.
Yeah. You can write 4 isomers. You have to just name the one which is prepared from propanone and methyl magnesium bromide. Done? How will you write the structures? 4 carbon atoms, right? So the first structure is 1, 2, 3, 4. And you put a OH here, right? What is the name of this alcohol? Who will tell me?
Butanol, ma'am.
Butanol. Which butanol?
One butanol, ma'am.
1 butanol. Again, you can
Two
write,
butanol, ma'am.
then you can write 2 butanol, right?
Three
This is
butanol,
2.
ma'am.
2. Can you have 3
No,
butanol?
ma'am. Sorry.
Then the third one is you can have a branch. So 1, 2, 3, and here, and OH is here. CH3, CH3, CH, CH2, OH. And the fourth one is CH3 and OH here this time. Right? And a OH here. Now, what type of alcohol is the first one? Can you tell me what type of alcohol is the first one?
First one, ma'am. Primary alcohol, ma'am.
First one is primary alcohol. Second one is secondary
Secondary,
alcohol.
ma'am. No, it's
Third
also
one.
secondary, ma'am.
No, third one is also which type? This carbon is attached to only
Oh,
one.
sorry, ma'am. Sorry, ma'am. It's a primary, ma'am.
And third one is
Tertiary, ma'am.
tertiary, right? Now, according to the rules of Grignard, When one it is a ketone and Grignard reagent. What type of alcohol can you prepare with ketone and Grignard reagent? Hari Raghav, you answer this time. I have a ketone, propanone and Grignard reagent. Which alcohol can be prepared by ketone and Grignard reagent? Are you there, Hari
I'm sure
Raghav?
tell from that page, ma'am.
What is it? We have done 3 rules of Grignard reagent, isn't it? First is
Yes.
formaldehyde or methanol and Grignard reagent. When it is formaldehyde and Grignard reagent, you get primary alcohol. When it is any other aldehyde and Grignard reagent, you get secondary alcohol. And when it is a ketone and Grignard reagent, you get a tertiary alcohol. So when I have a ketone and Grignard reagent, which alcohol can I prepare with this? A tertiary. Which is a tertiary alcohol? The fourth
I'm
one.
the fourth one.
Yes.
Ma'am, I have doubt.
Yes, tell me.
Ma'am, for tertiary, the boiling point increases or decreases, ma'am?
For tertiary alcohols, see, in these isomeric alcohols, the one which is straight chain, this first one will have the highest boiling point. Then OH in the middle. Then this branch. And the lowest boiling point will be of this tertiary, fourth one.
So
Not
ketone
degree.
has lowest boiling point.
Which one?
Ketone has lowest boiling point.
No, not ketone, tertiary alcohol. This is an alcohol.
Okay.
Tertiary alcohol will have a lowest boiling point because their intermolecular force of attraction will be less. That is why. Okay.
Okay.
Now let us quickly revise what are the rules of Grignard reagent that we have learned. If you have to prepare a primary alcohol, you have to take CH2O, that is methanol, plus Grignard reagent. Okay, any Grignard reagent depending on the product that you want. Right? If I have any other aldehydes, RCHO plus Grignard reagent, what will I get? Secondary alcohol. This gives me what? Primary alcohol. And if I take a ketone plus Grignard reagent, I will get a tertiary alcohol. So these are things you should remember and not forget. Now we'll go by your textbook. So this, you have to tell me the IUPAC names of this. We'll not do all of them. We will do only few. Let's see whether you can answer. One by one, I'll call your name and you tell me. So Sai Kalyan, can you tell me the name of the first one? Sai Kalyan, are you there?
Yes, miss.
Can you tell me the name of the first one?
Just 2 minutes, miss. I'll say.
And Hariharan, you tell me the name of the fourth one.
Fourth one, ma'am.
Fourth one, Sai Kalyan will tell me the name of the first
glycerin,
one.
ma'am.
Yes, that is the common name. I want the IUPAC.
Propane trial, ma'am.
So propane
1, 2, 3 trial, ma'am.
Propane 1, 2, 3 triol. Very good. Okay. Hari Raghav.
Miss.
Yes.
Miss. Secant pentyl 2, 2, 4 trimethyl alcohol, miss.
2, 2, 4 trimethyl, then
sec pentyl alcohol.
Pentan, you don't have to say alcohol. Pentan, where is the position of OH group? Pentan 3-ol. Okay, or you can call it 3-pentanol. You understand the name?
Okay.
Pentan 3-ol, you have to write. So this is 1, this is 2, this is 3, this is 4, this is 5. So 2,2,4 trimethyl, that is correct. Pentan 3-ol, that means on the third carbon you have a OH. So pentan 3-ol. All right. Or you can also write it as 3-pentanol. 3-pentanol. Now this one was propane 1,2,3-triol. Now Hari Raghav. Can you tell me the name of the second one?
1 minute, ma'am.
Hmm. Sai Kalyan, now you should find the name of the 9th one. And Hariharan,
Yes,
you
ma'am.
should tell me the name of the 6th one. Okay, just say when I call your name. I am now giving time to Hari Raghav. What is the name of the second one?
Ma'am, is it 1, is it 2, 4 heptanol?
Okay, 2,4. Now that is first, what you should do first? Longest chain. So what is the longest chain? 1, 2, 3, 4, 5, 6, and 7. So hept,
Heptane.
right? Heptane. So what will I write? Heptane, heptane, 2, 4, and 2 OH are there. So 2, 4 diol. And what is there on? This is 1, 2,
5
3.
butanol. 5 butane.
So 5, what is this? 5
That's butane.
ethyl. 5 ethyl. Right? Did you understand?
Yes, ma'am.
5
Okay.
ethyl 2, 4 heptane diol, or 5 ethyl heptane 2, 4 diol. Okay. And this is propane 1,2,3-triol. Now, Sai Kalyan, can you tell me the name of the 9th one?
Miss,
What is the longest?
2-methyl
2-methyl.
2-methyl propane methoxymethane.
2-methyl, and then you should write this branch, right? So 2-methyl, 1-methoxy.
Okay, miss.
2-methyl, 1-methoxy propane. Did you understand, Sai Kalyan? And it should be actually 1-methoxy 2-methyl, because it should be in alphabetic order. So methoxy should come here. So 1-methoxy 2-methyl propane. So this is the longest chain. And on this chain, on the second carbon, you have methyl. On the first carbon, what do you have? Methoxy. This is 1, 2, and 3. So 1-methoxy 2-methyl propane. Did you understand, Sai Kalyan? Sai Kalyan? Hello?
Yes,
What
miss.
happened? Did you understand
Yes,
the
miss.
naming? Okay. Now the 6th one, Hariharan.
Ma'am, 4-methyl phenol, ma'am, or
Yes.
orthography.
1, 2, 3, 4. So you can call it 4-methyl
Paraprasal, ma'am.
phenol, or you can also call it paracrisol. That's also correct. That's common name, and this is IUPAC. So like that, you can name all of them. Okay. Now let us go to the next one, where you have the names and you have to write the structure. Okay. So we'll practice 1 or 2 out of these. So you have to write first one, 2-methyl butane 2-ol. So if the structure is there, it is not difficult to write. So what is the word root? But. So what will I do? 4 carbon atom. 1, 2, 3, 4. Butane 2-ol. So if this is 1, this is 2, this is 3, this is 4. So on the second carbon, I have OH. And on the second itself, I have methyl. Now you fill up the hydrogens. This is the structure of 2-methyl butane 2-ol. All right. Now, if I have to write the third one, what is this? The word root is hex. So this is the first one. The third one, how will I write? The word root is hex. So you can have how
Yes,
many
ma'am.
carbon atoms? 6. Right? Then 1,3,5 triol. On first carbon atom OH, on the third carbon atom OH, on the fifth carbon atom also OH. Then on the third and fifth carbon atom, you also have the methyl. So here you have CH3, 3, 5. 1, 2, 3, 4, 5. And here also you have CH3, 1, 3, 5, 1, 3, 5. There is a mistake in this name. You can't have a methyl branch of a hexane it is. So 6 carbon atoms. Hexane and here methyl. So this is the structure of 1,3,5 trimethyl hexane. Dimethyl hexane. 1,3,5 3,5 dimethyl hexane. So this is the structure. Now you have to write, say for example, 2,3-diethyl phenol. 2,3-diethyl phenol. So let me write the fourth one. How will I write? First write phenol. Okay, this is phenol, OH directly attached to the benzene ring. Now wherever OH is attached, this is carbon 1, this is 2, this is 3, this is 4, 5, and 6. So I have to write ethyl group where? On second and third. So how will I write? I will put it on the ethyl group. I can put on the second and third carbon atoms. What is ethyl? C2H5. Here also what? C2H5. So that is the fourth one. Okay. Now cyclohexyl methanol. Cyclohexyl methanol. So how will I write the seventh one? This is the seventh one. Cyclohexyl methanol. So what is methanol? CH3OH. Cyclohexyl means on this first carbon atom, instead of hydrogen, it is cyclohexyl group. So what is that? This is cyclohexyl methanol. Okay, don't confuse it with benzyl alcohol. Benzyl alcohol, this one will have a ring. Then it will become benzyl. But what are we making? Cyclohexyl methanol. 1-ethoxypropane, the fifth one. 1-ethoxypropane. Let me write it there itself. The fifth one. I'll reduce the size of this one. Okay. And here I will write 1-ethoxypropane. That is the fifth one. So for the fifth one, 1-ethoxypropane. So this is propane, 3 carbon atoms. On the first carbon atom, there is ethoxy. So OC2H5, CH2, CH2, CH3. So this is 1-ethoxypropane. Okay, so like that you have to write all the names. I think you should be able to write all of them. Okay. The next question is, explain why propanol has higher boiling point than that of hydrocarbon butane. Okay, so propanol is CH3, CH2, CH2OH, and this is CH butane. Who will tell me why? Which has higher boiling point? They are saying propanol, although it has only 3 carbon atoms, it has higher boiling point than butane.
It's alcohol, ma'am. It has alcohol functional group, ma'am.
So alcohol functional group saying that is not enough.
Because it can
What?
form hydrogen bonds with water.
Yes, because of hydrogen bonding. You just have to mention hydrogen bonding. So due to hydrogen bonding, alcohols have higher boiling point than alkanes. Then the second one, alcohols are comparatively more soluble in water than hydrocarbons of same molecular mass. So why is, if I take this example only, propanol is soluble in water, but butane is not soluble in water. Why alcohols are soluble and alkanes are not soluble?
Because the alkene part is hydrophobic part.
Yeah, this is alkane part is hydrophobic, and moreover, alcohols form hydrogen bonds with water. So due to hydrogen bonding with water molecules. So all physical properties of alcohols can be explained by hydrogen bonding. Why they have higher boiling point? Because of hydrogen bonding. Why they are water soluble? Because they form hydrogen bonds with water also. So they can form hydrogen bonds with water, so they are water soluble. Alkanes have hydrophobic chains, so they are not soluble in water. Did you understand, all of you? Now the next question, just one more question, let's see. Okay, two more questions now. They are all from your textbook. So this is question number, I can tell you the question number if somebody is following the book. This is question number 11.8 and 11.9 and 11.11. So while separating mixture of ortho and para nitrophenol by steam distillation, name the isomer which will be steam volatile. Which isomer will be steam volatile? That means which is more volatile than the other. So what is ortho and para nitrophenol? Sai Kalyan, will you explain this?
I should give the answer. I should explain what is orthonitrophenol.
Huh. So what is ortho nitrophenol? This one.
Yes, miss.
And para nitrophenol. Right? How will you explain which one is steam volatile, which has a lower boiling point or has almost same steam volatile means if I pass steam through the mixture, one of them which has a boiling point close to steam or less than steam will go off with steam. With first tell me which of them will have a lower boiling point, one or two? Which will have one will have a lower boiling point, right? Why will one have a lower boiling point? Only one word answer is there.
Intramolecular hydrogen bonding.
Yes, there is intramolecular H bonding. So its boiling point will be low. And this is intermolecular hydrogen bonding, right? So hydrogen bonding, because of which the boiling point will be higher. So the one which has lower boiling point will be steam volatile. Write equations for the reaction of preparation of phenol from cumene. Do you remember this? Phenol from cumene. I think Sai Kalyan, you were absent on that day.
I know, miss. I know.
You have written. So what is cumene on the benzene ring?
CH and then CH3 on both sides.
Yes, CH and CH3 on both sides, right? So first what you do is you treat it oxidize, and so you will get cumene hydroperoxide, right? CH3, CH3, and here O and O and H, a hydroperoxide of cumene. And then if I react it with H2O and H plus, it gives me phenol. And you know what is the byproduct here? It is propanol. You can see it and understand how it will be formed. So that is the cumene process. The next one is write chemical reaction or preparation of phenol from chlorobenzene. Hari Raghav, can you tell me how I can prepare phenol from chlorobenzene? So I have to begin with chlorobenzene. And what do I have to prepare? Phenol. How will I do that? Who will tell me? Just think, Hari Raghav, you can
Ma'am, by
answer.
adding aqueous NaOH.
Very good. Aqueous NaOH. But what you have to remember here is that this reaction cannot take place easily. So two things we have to remember. First, the reaction requires high temperature and pressure. So if I take 623 Kelvin and about 300 atmosphere pressure, under these conditions only, NaOH will react with nucleophilic substitution will happen. Cl will be replaced by OH and you will get phenol. And in addition to this, NaOH, which is there as a reactant, reacts with phenol and gives you sodium phenoxide. So first, you will not get phenol directly. You will get only sodium phenoxide. And then when you add H+, that is a specialty of this reaction, you will get phenol. So either you write NaOH and below that here somewhere you write H+, then you can write phenol directly. Otherwise you form sodium phenoxide and then react it with H+ to get back phenol. Why do you get sodium phenoxide? Because phenol formed immediately reacts with sodium hydroxide to form salt and water. Okay. So that is the answer for this question. Now let us do one more. Okay. Show how you will synthesize 1-phenyl ethanol from a suitable alkene. Okay, 1-phenyl ethanol. We should write first 1-phenyl ethanol. So what is it that you want to prepare? Ethanol. So CH2, CH2OH. And here I have the phenyl group. So phenyl group is C6H5. So I can write C6H5. So what do I need to prepare? C6H5, CH2, CH2OH. It can also be written with the benzene ring. Both are same. CH2, CH2OH. Now the question is, there is an alkene which gives me this. Which alkene can give? So you have to first form the alkene. Now what sort of reaction has given me this? This, if I have to prepare it from alkene, it is by addition of water in presence of H+. So from here, if I remove alcohol, so if I remove water, OH and H, which alkene will I get? CH double bond CH2. Okay, so this is 1-phenyl ethene. 1-phenyl ethene. It is commonly known as styrene. So styrene on addition of water gives me 1-phenyl ethanol. Okay, 1-phenyl ethanol. Second question, cyclohexyl methanol using alkyl halide by SN2 reaction. Cyclohexyl methanol. Let us see what is cyclohexyl methanol. I showed you just now. This is cyclohexyl group. Methanol means CH2OH, right? And I need to prepare it from a primary alkyl halide because the reaction has to be what? SN2 mechanism. So I can use only a primary alkyl halide. So which alkyl halide will I? There is no ring inside there. cyclohexyl, and alkyl halide will be CH2Cl. And what will be the reagent that I will use? Aqueous NaOH. So with aqueous NaOH, Cl will be replaced by OH, and the mechanism will be SN2. Cl will go from one side, and CH2, the OH will come from the other side. So that is preparation of cyclohexyl methanol. Third one is
Miss,
pentan. Yes.
asking the alkene one, miss. So shouldn't we? This answer is okay, but if we write CH3, then also it is okay on this.
CH3 where?
Where you wrote CH2Cl rather than replace, rather than doing the chlorination again, can we CH3 can be right?
By using alkyl halide. We have to use a alkyl halide. So I wrote this one.
Oh, okay, miss. Okay, miss. I thought
Okay.
alkene was the question.
Yeah, yeah. Then the next one, third one is you have to prepare pentan 1-ol using suitable alkyl halide. So first write pentan 1-ol, 5 carbon atoms, and here is your OH. Okay. So what alkyl halide should I use to get this one? Tell me. Again, I have to use aqueous NaOH, right? Which alkyl halide will I use?
N-pentyl chloride, miss.
N-pentyl chloride, Cl. Okay. So wherever there was OH, you have to just put Cl there. N-pentyl chloride. Very good. Now let us do one more question. What is the chat? Please, so everybody has opened the camera. Hari Raghav. Also, please switch on your camera.
Ma'am, yes, ma'am.
Yeah. Then next question is, I'll take one more question now. Give equations for the following reactions. Let me write it here. Right. Now, give equations for the following reactions. Tell me. Oxidation of propan 1-ol with alkaline KMnO4. Okay, so propan 1-ol. So what is propan 1-ol? CH3, CH2, CH2OH, right? And I have to prepare from here, which one? What is the reagent I have to use? Alkaline KMnO4. That means oxidizing agent. What type of alcohol is this? Can you tell me? Is it primary, secondary, or tertiary alcohol?
Primary.
It is primary alcohol. And primary alcohol on oxidation gives me what? Primary alcohol on oxidation gives me what? On oxidation, alcohols give me what? Sai Kalyan, have you read this part?
Yes, primary alcohol, it reacts with KMnO4, it will give carboxylic acid.
Carboxylic acid. Which acid will it give? Hariharan? Which acid will it give?
Propanoic acid, ma'am.
Very good. Propanoic acid. So remember, it's a strong oxidizing agent. You will get an acid. Now, bromine with carbon disulfide with phenol. Okay, so I have phenol here. And what is the reagent I am using? Bromine in presence of what? Carbon disulfide, which is a non-polar solvent. What is the product that I will get? Hari Raghav, can you tell me the product? Hari Raghav, you are not answering well. Tell me.
No, 1 minute.
You don't know. Okay. Hari Haran, can you tell me?
Ma'am,
Ma'am,
Hmm.
ma'am, will it be in ortho, ma'am, or co-bromo?
Yes. So you should try ortho, very good. And para-bromophenol. Once you make an effort to answer, no, you will not forget this answer. So you must try. So if I take bromine and carbon disulfide, I will get ortho and para-bromophenol. Got it? Now, in case I use dilute nitric acid with phenol. So the third one is dilute nitric acid with phenol. So I have phenol and I'm reacting it with dilute HNO3, right? Now tell me, Hariharan, what will I
ma'am,
get?
ortho or para-nitrophenol, ma'am.
Yes, so you will get ortho and para-nitrophenol. If I had taken concentrated nitric acid,
Trinitrophenol, ma'am. Picric
then I
acid.
would get trinitrophenol. Very good, very good. Then the fourth question is phenol with chloroform and aqueous NaOH. So phenol, and I am reacting it with chloroform, CHCl3, and aqueous NaOH, right? Do you remember this reaction? First, can anyone tell me the name of this reaction? Any one of you? Do you remember the name of this reaction? I told you it's an important reaction. It is called Reamer-Tymans reaction. Reamer-Tymans reaction. And you get a very interesting product here. The product that you get is this one. You will have to learn properly. The CH from here you should recall. You will get CHO. What is this?
Salicylaldehyde, ma'am.
Yes, salicylaldehyde. Right? So that is Reamer-Tymans reaction. Okay, do you now understand? Okay. Now let us do the next question. So one by one, all of you have to answer this. You have to name the reagents used in the following reactions. You have to tell me the name of the reagent. Which reagent will give me the product? Okay. So tell me. Oxidation of primary alcohol to carboxylic acid. Tell me.
Ma'am, alkaline aqueous KMNO4, ma'am. KMNO.
KMNO4. So alkaline KMNO4 will give me this product. Oxidation of primary alcohol to aldehyde. Sai Kalyan.
Plus copper.
Yeah, copper, just the temperature 573 Kelvin. You have to write the temperature. Otherwise, you can also write PCC. Bromination of phenol to give 2,4,6 tribromophenol. Yes, tell me.
At 513 Kelvin, it will give an alkene bonus.
No, it gives an alkene if your sulfuric acid is at 170. Copper always, copper and 573 can give alkene only from tertiary alcohol. Primary alcohol will give aldehyde. Secondary alcohol will give ketone. All right. Bromination of phenol to give 2,4,6 tribromophenol. This is the right question for you, Hari Raghav. Tell me. Just now you told me you saw how you can get from phenol ortho and para-bromophenol. Now I want to get 2,4,6 tribromophenol. What will I do? When I took bromine and carbon disulfide, I got ortho or para. If I take bromine and which reagent? Bromine water. Understood? Why with bromine water? Because water is polar solvent. So it will give Substitution at ortho and para. So 2,4,6 tribromophenol. Okay. Then benzyl alcohol to benzoic acid.
Ma'am, alkaline KMNO4, ma'am.
Yes, alkaline KMNO4. Very good. Then dehydration of propanol to propene, Cyclean.
Miss, concentrated H2SO4.
Concentrated H2SO4. You have to write the temperature 270 or 170 degrees Celsius, or you can write it in Kelvin. So 170, because at 140 you will get ether, at 170 you get alkene. Butanone to 2-butanol.
Ma'am, reducing agent, ma'am.
Reducing agent. Which
Lithium
reducing
aluminum hydride or sodium borohydride, ma'am.
Very good. Lithium aluminum hydride or NaBH4. Hariharan, you are well prepared for the test tomorrow. I am so happy. Okay. Now we'll take the next question. Okay. This time we have come to ethers. Write the names of the reagents and equations for the preparation of the following. Okay. So first I have to prepare propoxypropane. So let us first write what propoxypropane is. So propane is 3 carbon atom. Propoxy is O and again 3 carbon atoms on this side. Right? So what is it? Propoxypropane. Now this is what type of ether? This is a simple ether. So we can easily decide how to make it. One will form the alkoxide and the other will form alkyl halide. So it doesn't matter which one is which. So I can make it from CH3, CH2, CH2, Cl plus CH3, CH2, CH2, ONA. Did you understand, all three of you? Cyclean, since it's a simple ether, I can make alkyl halide propyl chloride and sodium propoxide. So it is easy here. Now supposing I have to prepare the second one. This is first, now the second one. Second one is ethoxybenzene. So what is ethoxybenzene? C2H5O, and on this side you have the benzene ring. Now which combination will give me, by Williamson's reaction, which will be the alkyl halide and which will be the alkoxide? Hariharan, can you tell me?
Ma'am, chlorobenzene, ma'am, and sodium salt of ethane, ma'am.
No, this bond doesn't break.
Oh,
You know,
yes, ma'am, yes,
chlorobenzene.
ma'am, yes, ma'am, yes, ma'am.
Yeah, so I will take this as phenoxide, right? Sodium phenoxide and C2H5Cl, right? If I put a chlorine here, that bond will not break easily. Any element directly attached to benzene ring, that bond doesn't break easily. So you have to keep that in mind. Then the third one, 2-methoxy, 2-methyl propane. So let us write, this is propane. 2-methoxy, here OCH3, and 2-methyl, here CH3. Right? 2-methoxy, 2-methyl propane. Now who will tell me? Cyclean, can you tell me which combination? One side it is tertiary, one side it is primary. I will write
CH3 and name this.
Right. Where will I put Cl and where will I put alkoxide?
Alkoxide at CH3, Miss.
No. This will be Cl and this will be ONA. Can you understand the reason why? Sai Kalyan, can you understand the reason? Reason is that when the mechanism follows, in this case, it will follow SN2 mechanism. In SN2 mechanism, substitution product is formed more easily. If I had taken the one which you are saying, that is CH3CH, right? Cl plus CH3ONA. Then what will happen? This CH3Cl, you know it ionizes quickly and it will give me a carbocation. So carbocation, it forms quickly and the mechanism becomes SN1 mechanism. Now here, this carbocation has this nucleophile. What is the nucleophile here? CH3O minus. CH3O minus is a strong base. So what it does, it takes H from here and converts it into an alkene. It is not substitution, it becomes elimination reaction. So whenever you are having tertiary alkyl halide, elimination product is going to be a major product if your reagent is a strong base because carbocation is formed. If instead of this, the reagent was OH only, then it would have added here and caused substitution. But here your reagent is a strong base, and strong base, it takes away a proton from the substrate and it will become CH3OH, right? Last year you have learned anything which is a weak acid is a strong base, isn't it? Has a strong conjugate base. So CH3OH is a weak acid. So its conjugate base is a strong base. It will take H very quickly from this and give you substitute. But if I take CH3Cl, then the mechanism is SN1. The Cl goes from here and this whole molecule will attack from the back side and you will get this product. Okay. So when one side it is tertiary and one side it is primary alkyl group, then tertiary will form the alkoxide and primary will form the alkyl halide. Okay. Now last one, methoxyethane. So,
Miss,
yeah,
Miss, under Williamson synthesis, will all the ethers undergo SN2 reaction?
yes. In if we want the ethers to undergo SN2 reaction, then only by Williamson's reaction, the better yield will be there if the reaction is SN2. So if you have a choice of conducting it by SN1 or SN2, then choose SN2. Okay. Now here in this case, right, here if I take SN2, then I'll have to decide which will form the alkyl halide and which will form the alkoxide by the size, steric hindrance. So here also CH3Cl, and what will be the alkoxide? CH3CH2ONA. The larger group should be the alkoxide. Smaller group should be the alkyl halide. Why? Because in SN2, steric hindrance also is important because the reaction has a back side attack. So if the back is very heavy, the attack from the back will be difficult. So here, backside attack is more difficult. Here it is easy. So this will be the combination for Williamson's reaction.
Miss?
Yes, tell me.
Miss, in SN2 reaction, will tertiary alcohols have less steric hindrance?
What is it? I didn't get you.
Miss, SN2 reaction, less steric hindrance will be according to the reactivity, which is directly
less steric,
proportional.
yeah, less. See, among primary alkyl halides, the one which has less steric hindrance, that means there are bulky groups are not present, that will have less steric hindrance. And if it has less steric hindrance, then it will undergo SN2 more easily. All right.
That means tertiary alcohols have less steric hindrance in SN2.
Tertiary alcohols
Mm.
will have tertiary
Not
alcohol.
alcohols,
No,
not
no,
alcohols,
no, no, no.
fatty levels.
See, tertiary, if tertiary alkyl group is present, it has tremendous steric hindrance. See, 3-methyl groups. You look at this compound. Now you see 3-methyl groups around it. Right? CH3, CH3, CH3. First of all, whenever tertiary group is there, a carbocation will be formed. And then the reaction will be SN1. First carbocation, then the nucleophile. But if it is primary alkyl halide, then the then I'm not talking of alcohols, we are talking of alkyl halides, reaction of alkyl halides. All right. Now what will happen? You compare this one and CH3Cl, which has greater steric hindrance. This has greater steric hindrance. So this will undergo SN1, SN2 more easily. This one will anyway not undergo SN1, SN2. It will undergo SN1. So this will undergo SN1, this will undergo SN2. When it undergoes SN2, then steric hindrance plays an important role. This cannot undergo SN2, one also because of steric hindrance, and the second because it forms a carbocation, a stable carbocation, which is a tertiary carbocation. Okay, now let us do the next question. Now, if I do all the questions no, then you will know all the whole paper because all the questions we are solving here. Write the reaction. Okay, now we'll do this one because always these two will confuse. Control Shift S. Write the reaction of right. So next question. This is the opposite here. You have to see carefully. This time we are writing the reaction with HI. So 1-propoxy propane. Okay, so CH3, CH2, CH2O, CH2, CH2, CH3 with HI. Here there is no problem. It is simple ether. So propyl iodide and propyl alcohol, right? There is no problem. You can write I here and H here. Doesn't matter. Okay. Now methoxybenzene. So this is benzene. And this is methoxybenzene plus HI. Now Hariharan, tell me, what will I get? Where will H go? Where will I go?
Ma'am, H will go to the benzene
I,
side, ma'am.
yes, benzene side. And
And
H,
H,
yeah. So here you will get phenol and here you will get
iodomethane, ma'am.
iodine. So you always, generally you will get the smaller alkyl group. Okay. Now let us see benzyl ethyl ether. Methoxybenzene, then benzyl ethyl ether. So this is benzyl and this is ethyl, ethoxybenzene with HI. This is also easy. Cyclion, you will get what? Phenol plus C2H5I. When one side it is alkyl benzyl group. No, sorry, this is benzyl ethyl ether. I have made a mistake. CH2O, CH2, CH3 and HI. Now what will happen? Which side will the carbocation be formed more easily? Now this benzyl carbocation is very stable, isn't it? So the bond will break here. So what will I get? I will get CH3, CH2OH plus this one, CH2I. Why did I do it like this? Because in this case, this bond does not break easily. This will not break. But in this case, this bond will break easily and I will come here and H will come here. Why? Because benzyl carbocation is stabilizes by what? By resonance. It stabilizes by resonance. So carbocation will be formed, and after addition of a carbocation, the nucleophile, which is I, will come and attach here. Okay, let me show you this one here. CH2 and OCH3, right? It will break easily and give you this carbocation, CH2 plus. Now this carbocation you can see here, CH2 and plus. It stabilizes by resonance. These electrons will move here, then this will move here, this will move here. So this will be resonance stabilized. So this will be formed and H is already there, right? So this will form first carbocation and this will react with I minus. So that will form the alcohol and this will form the iodide, CH2. So each one you have to look at it very carefully and then understand what are the products that you get. So this is a typical one. Two reactions are there. One where you have to tell which combination of alkyl halide and alkoxide will give the correct ether, and the other, if you know the ether, what will be the product when it react with HI, which alcohol and which alkyl halide. So think, understand, and then answer these questions. They are typical questions for MCQs also, so you should be able to do that. Then explain the fact. Okay, let us practice this control. You are here again, you just have to tell me the reagent. Which reagent will give the correct product? Tell me. Write the equations for the following. I am saying don't, I'm not interested in the equation. Just tell me for the first one, which reagent will you use to get this product? Friedel-Crafts reaction, alkylation of anisole. Let us write.
Anhydrous AlCl3, ma'am.
Yes. So you will write anisole is this one. And for alkylation, you can use anything, CH3Cl, and with anhydrous AlCl3, right? You will get the product which is orthomethyl methoxybenzene or orthomethoxytoluene, anything you can write. First one. Second one is nitration of anisole. Anisole is OCH3. Hari Raghav, tell me, what is the reagent that we use?
It can be done with HNO3, ma'am.
Yes, concentrated HNO3 and H2SO4, right? So you will get orthomethoxy nitrobenzene and also para nitrobenzene. Bromination of anisole in ethanoic acid medium. What is the product that you will get? So bromination means bromination of anisole. This is anisole, right? Bromination in presence of acetic acid. What will be the product? Sai Kalyan, you were there when I taught this. Tell me, where will the BR come? On which position? On ortho, para, or meta? Ortho and para. So this plus in para position. OCH3 and here CH. Very good. Now the last one, Friedel-Crafts acetylation of anisole. Hariharan, now tell me. Anisole and Friedel-Crafts acetylation means CH3COCl in presence of AlCl3. What will you get? What will you get? What will come on the benzene ring? COCH.
CO.
Okay, this is orthomethoxy acetophenone. This group forms acetophenone. It is like a ketone. On one side benzene, on one side CH3. It is known as acetophenone. So orthomethoxy acetophenone and paramethoxy acetophenone. Okay. Now let us do one more question. We are literally done with the whole paper. Tell me. Show how you would synthesize the following alcohols from the appropriate alkene. Which alkene? This alcohol, how will I prepare from alkene? So let me write the alcohol here. CH3 and OH. Now when you are preparing from alkene, how would you have prepared? By removal of water, dehydration. So which product, what is the dehydrated product of this one? OH and H from the adjacent carbon atom.
Is it a ketone, ma'am?
Not ketone. You will get an alkene. So OH will go from here and H should go from the adjacent carbon atom. There are two adjacent carbon atoms. One is CH3 and one is CH2. But I told you, poor becomes poorer. So this is concentrated H2SO4, temperature 170. I should find out which alkene will I get. So the alkene that I will get is here CH3 and CH2. This is the alkene which on addition of water will give me this alcohol. If I add water, what will happen? H will go here and OH will come on this carbon where there's less number of hydrogen atoms. Okay. Next one. Now take the second one. Second one is the C carefully. Here there is OH and here there is a CH3 here. Now I have to remove OH. So I'll remove OH from here and H from the adjacent carbon atom. Here, which are the adjacent carbon atom? One is this carbon atom here, one is this carbon atom here, and one is this one. Now these carbon atoms have two hydrogens. This carbon atom has three. So either I can remove from here or from here. So what will be the product? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7. There is a CH3 here, and this will be the double. This alkene on addition of water will give me this alcohol. So you should learn how to remove water. Now the third one, how will I remove water? 1, 2, 3, 4. And here is my OH. So if I remove water, I'll take this OH and H from this carbon atom. So what will be the alkene? 1, 2, 3, 4, and this is the alkene. Because on this alkene, if I add water, I will get this alcohol. Okay, so you should know how to remove water. You should also know how to add water. So you should be able to do left and right, and you should be able to be sure that your answer is right. Now the next one, the fourth one. How will I do the fourth one? So let us write, this is my benzene ring. No, this is my cyclohexyl ring. 1, 2, 3, and 4. Here there is OH, and here there is CH3. There's one branch here also. So this is CH3. Let me write here, CH3. Here there is CH2, and here 1, 2, 3. Here there is CH. Now I want to remove water. So OH will go from here. H should go from the adjacent carbon atom. So where will H go from? Poor becomes poorer. So H will go from the carbon which has least number of hydrogen atoms. This carbon has 2, this carbon has 3, this has only 1. So this hydrogen will be lost. So what will be the product? This cyclohexyl. And here I'll get the double bond. This CH3, this and this. This will be the product. Are you getting? I took OH from here and H from here, and so a double bond is created here. Okay? So double bond is here. So we have done quite a few questions. Just go through your notes and just recall, learn the name reactions. Which are the name reactions you have to learn? You have to learn Reaumur-Tiemann reaction. You have to learn Kolb's reaction. And learn Grignard synthesis properly, go through the physical properties. You should be able to do the test well tomorrow. Okay, wish you all the very best. And thank you. Yes, tell me.
For the second one and third one, it is 4-methyl-eptoene and pentoene, miss.
Which one?
Second and third.
Second one, second. So it is second one is 1, 2, 3, 4, 1, 2, 3, 4. Yeah, 4-methyl. Oh, what the product that I got?
Yes, miss.
Second one. Yeah, so it is 1, 2, 3, 4, 5, 6, 7. So 4-methyl and hept 1, 2, 3, hept 3-ene. 4-methyl hept 3-ene, right? 1, 2, 3, 4. So 4-methyl hept 3-ene. Okay, any other doubt?
And for third one, it is pentoene, no, miss.
Pentoene, yes. 1, 2, 3, 4, 5. So pentoene or 2-pentene, whatever you want. Okay. So first of all, thank you very much for coming for the class today, because tomorrow was your test. Others have not come. So I want you to do very well so that others understand that skipping a class is not a good idea. Last time when there was an extra class, I canceled the class because I felt that when all are not there, it is not good to take a class, because that time I was about to teach phenols, which was difficult. But now this was a practice. I did it. I took the class, and thank you so much for being attentive and keeping your cameras on. All of you participated. Hari Raghav, you are capable. Please believe in yourself, revise and do well tomorrow. All right?
Yes, yes, ma'am.
Okay, all the best. Bye.
Thank you, ma'am.
Thank you, ma'am. Bye.